So far, we've learned about geometric sequences, and now we're moving into exponential equations. And what you'll see is that these are kind of the same thing. If I take a geometric sequence like 3, and let's say that I'm multiplying by 2, so 3 becomes 6, 6 becomes 12, 12 becomes 24, 24 becomes 48, and I keep multiplying by 2. And remember how this is a geometric sequence because we're multiplying. Remember how we can find a certain term, like we could find, say, the 10th term. And the way we do that is we start at 3, and every time we move forward, we multiply by 2. And to get to the 10th term, because I'm starting at the first term, I only have to multiply by 2 9 times, and that will give me the 10th term. 3 times 2 to the power of 9 ends up being 1,536. So this idea here can be generalized into an exponential equation. Y is the 1536, that's the number we ended up with, and 3 was the start, that was what we were multiplying by. This 2, remember it was called the common ratio, because if I make a fraction with any of these numbers and I take the current and divide it by the previous, notice that 48 divided by 24 is 2, 24 divided by 12 is 2, 12 divided by 6 is 2. I always get to the common ratio when I take current divided by previous. That common ratio in an exponential function we're going to call 1 plus r, where r is the rate or the percentage of growth or decay. Decay means it would be decreasing. Things that decrease are like radioactivity. Things decay over time. It gets less radioactive. Medicine, when you take any medicine, it decays in your body, and over time, the dose is less and less in your body. So the difference would be that if it's decay, rather than 1 plus r, it'll be 1 minus r, and if it's growth, you're increasing, it's going to be 1 plus r. So when you look at our original function, our original equation, 3 times 2 to the 9, the r is actually 1. Remember that 1 is 100%. It's 1 plus 1. That's how I got a 2 there. And that means when I look at that sequence, I'm increasing 100% every time. Do you see how 3 plus 3 is 6? 6 plus 6 is 12. 12 plus 12 is 24. 24 plus 24 is 48. We're increasing 100%. And so our exponent is what we are going to call time. How many years or months, whatever it is we're talking about, has gone by. And this is the way money grows in a bank account. If, for example, a bank account is monthly, but let's just go annual growth, meaning every year for a moment, then we'll get to monthly. But let's say that you invested $5,000 and you invested it at a rate of 10%. That would be 1 plus 0.1, which is 1.1 by the way. And the question would be, if that's every year, if I increase 10%, how much money would I have after 10 years? So if you plug this in the calculator, y equals 5,000 times 1.1 to the power of 10, and round that to the nearest cent. That means you're going to have 2 decimal spots. we would have in that case $12,968.71. So let's write that equation down again. Y equal the start, how much you're starting with, times 1 plus the rate. Remember, rate is the percent you're growing by, to the power of t time. So if I use this equation exactly as it is, it's annual growth, meaning every year you increase this percent or maybe decrease this percent if it's decaying. In your own bank downtown, if you have a bank account, they give you money monthly, not yearly. So that's just a little bit tricky. What you have to do is, let's say you have $1,000 in your bank account, and they don't give you very much money. Let's say that they give you 1%. That's 0.01. Well, that 1%, when you see it on the sign in front of your bank, is actually annual. And that's not the way they give you money. They give you money every month. So they actually, in real life, they divide that rate by 12 because there are 12 months in a year. But then you have to understand that going to the power of 12 is 1 year. What you've done is turn it into months, not years. So we go to the power of 12t. And if you had $1,000 and you get 1% interest, we can see how much money you would have in your savings account. 1 plus 0.01 divided by 12. Oh, again, let's say after 10 years. So that'll be the power of 12 times 10, which, by the way, if you punch that in the calculator, you'll need 12 times 10 in parentheses. Or how about you make it 120 first? This would be 1,001 plus 0.01 divided by 12. I punch it in exactly like that, to the power of 120. And you would have, after 10 years, 120 months, $1,105.12 to the nearest penny. 1% doesn't give you very much. Medicine in your body, it decays, but it's the same formula. If you take ibuprofen, if you take a 200 milligram dose, it decays in your body over time, maybe 25% per hour. So 1 plus R is actually 1 minus R, and 25% is 0.25. And then here your T is actually going to be in hours, not years, because we're talking about medicine. It's a different situation. And if you want to know how much is left of a 200 milligram dose of ibuprofen, 1 minus 0.25, by the way, is 0.75. After, say, 5 hours, this equation would tell you 200 times 0.75 to the power of 5, there would be 47.5 milligrams left in your body of ibuprofen if it decayed at 25% per hour. All medication, everything you've ever taken that's medicine, whether it be antibiotics, other medications, everything decays in your body over time using this kind of formula. Here's another example. Stocks pay dividends, and dividends are paid quarterly. That's 4 times a year. So your equation, y equal the start times 1 plus the rate to the power of t, has a little bit of a change here. Just like when we did monthly in the last example, stocks are quarterly, 4 times a year. They pay you money. Not all stocks do, some don't. But here's an example. Let's say you had a stock and you had $5,000 worth, and it paid an 8% quarterly dividend. Well, actually, it would be 8% annual dividend. So again, just like with the bank, you're going to take that 8%, which is actually annual, yearly. You're going to divide it by 4 because it's really quarterly. They give it to you 4 times a year. But then again, going to the power of 4 is just 1 year. So if I wanted to go 10 years, I'd have to go to the power of 4 times 10, which would be 40 months. And this is an example here. Look at the Desmos picture. You can punch out in Desmos exactly like you can do it on the calculator. This is the way to go to Desmos.com. Just make sure you put all the parentheses in the right spot. So if you had $5,000 of a stock that paid 8% quarterly, that $5,000 would become $11,040.20. Now, the last few examples I'm going to give you will be right from your assignment, and I'll put those in a separate video.